Okay, this problem comes from a statistics course, and it's a multiplicative law. The multiplicative law basically means that you can multiply probabilities, but you have to remember one thing. You have to remember, and I'll put this in red, with the multiplicative law, you have to remember with or without replacement. And before I do this problem, I'm going to skip to a real basic type problem.
Priority 1 message coming in on secured channel.
Bag of marbles. And the marbles have 4 red marbles, 3 black marbles, and 2 green marbles. Now, if I ask you what is the probability of picking 2 red marbles, probability of picking 2 red marbles, then you have 2 probabilities that you can do. The total is 4 and 3 is 7 plus 2 is 9. So 9 is the total. Now, if I'm going to pick 2 red marbles, I can put my hand in the bag and I'll pick 1 marble out. Now the probability of being red is going to be 4 out of 9. Now if I take that marble and I put it back in the bag, then that's with replacement. And then I just do 4 out of 9 again, or 4 out of 9 raised to the 2nd power. That is with replacement. So in other words, with replacement, the probability is not affected, because what are you doing after you pick the marble? You're putting it back in the bag. If you take, and without replacement, without replacement, you put the marble in your pocket after you pick it out. Now, without replacement affects the probability of the next draw. Okay, so if you pick a marble out of the bag and you put it in your pocket, then that changes the dynamic for the next pick out of the bag. So the probability without replacement of 2 reds would be, it's very important that you watch this, 4 out of 9 first draw, you put your marble in the pocket. And then the next one would be 3 out of 8, because you've got 1 marble in your pocket. And that's why the 4 drops to 3, because you're seeing what the probability is of the red. You don't know what color you have in your pocket, you just pick the one out. This is the probability of red. Okay, picking 2 marbles and they're both being red. That's why the 4 drops to 3, and that's why the 9 drops to 8. Now this is very, very, very important for you to understand, because it's going to drop each one. It's going to drop from the draw, and it's going to drop from the total. And when you're talking about a sock problem, in which there's many sock problems and probability, you're talking about without replacement. So in this problem, we're going to just go ahead and highlight the without replacement, because you're not going to pick out a sock and throw it back in, especially in the start, because you don't know what color it is. All right, and that's the problem. A person has 6 black socks and 8 white socks in the drawer. They pick out 2 socks in the dark. What is the chance? What is the probability that it is a mix of colors? That's what the question asks. Well, there's your answer. You've got 6 times 8, which is 48, over, I don't know what 14 times 3 is. Let's check. 14 times 3, or 13, sorry, is 182. And of course, this one would be 48 over 182. So your probability is 48 over 182, which comes out to be 48 divided by 182. And that comes out to be 0.26 probability, or a 26% chance that you've got. Now, they're asking you to add those two, and that depends on the question. Then you would get 96 out of 182, 96 out of 182, and that would come out to be, please work with me here, calculator, 0.53. Okay, so it depends on what the question's asking. But the main thing is, the whole process of the question is that you understand that each time you pick a sock out, the draw of the sock drops one. In this case, the 6 is, I'm sorry, not that way. The 6 is the number of socks, and the white is 8, so they don't drop. But up here, if you pick 2 black socks, this drops. 6 drops to 5, and 14 drops to 13. 8 drops to 7, and 14 drops to 13 because you're picking 2 white socks and just relate it back to the red marbles. Okay, so I hope that helps.